So great morning guys, great morning you people all. Today we're talking about one of the very important concept in refraction. So refraction, so that is n is equal to real depth by apparent depth. So depth. So many people struggling for what is the formula for refraction, refractive index. N is equal to real depth by apparent depth. So many people are struggling how to get this real depth by apparent depth. Already we have a formula that is equal to N is equal to C by V, that is equal to 3 into 10 power of 8 by V. Already we have a formula. So I want to derive this N is equal to real depth by apparent depth. I want to derive this one. So let's see guys here, for that I am taking one diagram. So let's see guys here, suppose this is water. So water is there here. So this is water. Okay guys, this is water. So water. So this is water here. Next this is air. We have air medium. Now I have a fish there inside of the water. Let us assume a fish is there inside of the water. So let us assume a fish is there inside of the water. One fish is there. Let us assume. So now what I am doing is that I want to get the image of that. Simply a right ray will project normal to the fish. So without deviation. So now what will happen guys? Now it is reflect. Why? Because it is a active surfaces. Start reflecting. So now it undergoes refraction now. We have two mediums here. One is water, another one is what guys? Air. So we have two mediums here. One is water, another one is air. So now what will happen? This is denser medium. This is what guys? This is rarer medium. So now what will happen? It is away from the normal line. So now it goes away from the normal line. So now I want to get the image. So certainly we have extended the refractor ray. Now I am extending the refractor ray now. So now here is the point where intersection is happening. So image will get in this area. So let us assume. So image will be get in this area. So image will be get in this part here. So image will get here. Let us assume. So let us say this is A, this is B guys, this is C. So this is the point where intersections are happening. So let us say ABC or three terms here. So generally we know that. So AC is called what? AC is called real depth. So everybody knows this. Real depth. And what is BC guys? So BC is called apparent depth. So apparent depth. Because of refraction, we see the image at B. So according to this, so now let's see the angles now. Let's say guys here. So this is what the normal line and the incident ray is called I. So automatically according to the transversal. So this is the line parallel to this line. So this become interior alternate angles. This is also become what guys? I. Now this is what here? This become what Nana? R. R means what? Angle of refraction. So once again same logic I am applying there. From this point and this point. This is a transversal line. Actually. So according to that corresponding angle. So this is R and this angle is also R. Why? Because both are corresponding angles. This and this are corresponding angles. So this angle is corresponding. So this angle is what guys? Corresponding angle. This angle is also what? Corresponding angle. This angle also what? A corresponding angle. These corresponding angles. So this is alternate interior angles. So this is also what guys? Alternate interior angles. Because of that, so both angles are equal. We know one of the great law, Snell's law in refraction. So what is that refraction, Snell's law? Let us assume this is N1 guys, this is N2. The refractive index of first medium is N1 and refractive index of second medium is N2. So now I am applying Snell's law. N1 sin I is equal to N2 sin R. Let us assume guys here I and R very small angles, comparatively very small angles. We know one of the formula in mathematics. For smaller angles, sin theta become what? Theta. So according to that, now what I am doing here, N1 I is equal to N2 R. We know once again, now I am in the place of theta, what can I write? I am using tan theta also for that, tan theta also I am using. So now I am doing is that N1 tan theta is equal to N2 tan R. So N2 tan R. So this is the formula I get right now. Let's see guys here now. Now N1 tan I is equal to what guys? N2 tan R. Now I am applying in the right angle triangle. Let assume this is so point is D. Let assume this is the point is D. So now what is the triangle guys? Let us one of the triangle A C D is a right angle triangle. A C D is a right angle triangle. Now applying tan I for that. So N1 tan I. So what is the formula for tan I guys? So now I am applying the formula. Here is tan I is there. Now I am applying the formula tan I. So tan I means opposite side by adjacent side. So opposite means what guys? CD the opposite side by what is the adjacent side? AC is the adjacent side. So AC is the adjacent side is equal to, next what I am getting here is that N2 into tan R. So what is the triangle we have to consider for tan R? Triangle BCD is a right angle triangle once again. BCD. So BCD is a right angle triangle. See guys here, BCD is a right angle triangle. So what I get from that? What I get? Tan R. Once again, opposite what will be there? CD is the opposite. What is adjacent? BC is the adjacent now. So BC is the adjacent. So what is the refractive index of A guys? 1. This is we don't know. Let us assume we don't know. N1 is we don't know. So N1 CD by AC. Now CD cancel. N1 by N2 is equal to AC by BC. N1 by N2 is equal to AC by BC. So just now we have all the code. N2 is equal to A. So what is the value of this? So N1 by A1 is equal to AC means what guys? AC means what? Real depth. So real depth by what about BC guys here? What about BC? BC is apparent depth. So finally what is the formula for refractive index? Real depth by apparent depth. So this is the formula for what guys? So refractive index. Thank you very much.